Hey everyone, in this video we're going to take a look at redox reactions, what they are and how to identify them. Now before we look at redox reactions, first we've got to remember from the last video how to find oxidation numbers. So as a refresher, at the top of the video, here's those 4 rules again. So when you see something like Cl2 gas, that's an atom in its elemental state, you can assign it an oxidation number of 0. Or aluminum fluoride, I can use rule 2 that says ions have an oxidation number equal to their charge. Aluminum's charge is +3. Or fluorine in rule 3 has an oxidation number of -1. And lastly, for polyatomic ions like SO4-2, I can use the 4th rule that tells me the sum of all these oxidation numbers have to add up to -2. So if oxygen's oxidation number is -2 and there's 4 of them, sulfur has to be a +6 to add to that total -2 charge. For more detail on how to do that, you can go back and rewatch the last video, but finding oxidation numbers is going to be extremely important for this video on redox reactions. So a redox reaction is defined as any reaction where electrons are transferred from one atom to another. And this happens all the time in all sorts of reactions that we're pretty familiar with, like this one between magnesium metal and oxygen gas. You've seen this probably in class or in videos online. The magnesium burns extremely brightly. What you can't see is that electrons are being transferred between the Mg and the O2 as this reaction takes place. And more specifically, it's the magnesium that's transferring its valence electrons to the oxygen. Some other important terms related to redox reactions: the atom that loses electrons is being oxidized, the atom that gains electrons is being reduced. That's also where this term redox comes from. The ox part of it comes from oxidized, the read part of it comes from reduced. So the term redox is short for oxidation-reduction reaction. These are also our key ideas for this video. Make sure you pause, take a moment, and write them down. Lastly, we'll take a look at how to identify redox reactions. Pretty much you just have to check the oxidation numbers for all the atoms in the reactants, then check the oxidation numbers for those same atoms in the products, and once you've done that, look to see if any oxidation numbers have changed. If oxidation numbers have changed, that means electrons must have been transferred. That means you've got yourself a redox reaction. Let's bring back my magnesium and oxygen reaction one last time and use our oxidation number rules to assign oxidation numbers to all the atoms in the reactants and also in the products. That's easy for Mg and O2 because they're both elements, so they're both automatically going to be 0. Here in the products though, now they're in a compound, specifically an ionic compound, so I can go by the charges of these two atoms, Mg with a +2, oxygen with a -2. So to make this easier to spot, let's cover up the oxygens. You can see that the Mg goes from 0 to +2. The only way that change in oxidation number can happen is if electrons were transferred. You'll see it with the oxygens also going from 0 to -2. Electrons must be transferred to make this happen. Since the oxidation numbers are changing, this is a redox reaction. Here's a second example, the reaction between sodium chloride and lead iodide. These are all ionic substances, so all I need to do is look up their charges. +1, -1, +2, -1. Sodium iodide in the products, +1, -1, and +2, -1. Here in this equation, all the oxidation numbers stay exactly the same. Sodium, for example, is +1 in the reactants, and it's +1 in the products. And that's true for each atom in the equation. Since none of them change their oxidation numbers, this would not be a redox reaction. And that concludes this video on redox reactions and how to identify them. Thanks for watching.